Hey, this is Chris Jenkins. It is December 5th, 2015. This is a video I'm posting for Physics 102, Embry-Riddle Online Worldwide for Professor Fred Vessel physics class. This is week 7. We're dealing with electric circuits. And I'm going to be talking about PLCs, Programmable Logic Controllers. And there's a unit that I used to work with called the SG2. This is what the unit looks like. And SG2 uses ladder logic, which is a graphical programming language that's designed for electricians who don't know how to code but need to program a machine for automation process. One of the cool things about the software for the SG2 is it's free. So you can get it here, www.factorymation.com/downloads. If you forget this, you can just Google SG2. That's the name of the PLC controller. SG2 programming software is down here at the bottom, and if you click that link, it'll give you a download. And I'm going to cancel this because I've already downloaded it. And once you're on the setup, it'll bring you here. Basically, the way this works is we can program the ladder. You got one rung on the left, one rung on the right, and when you get a circuit that goes from left to the right, then you're going to get current flow. And so it'd probably be easier for me just to kind of show you. Alright, I've put I01, so that's input, and if we flip back over to the unit, you would actually hardwire this. You would wire it up with inputs. An input could be a push button, a switch. It could be an electronic signal that comes from a pressure sensor, temperature sensor. So it could be direct or indirect. And then out here we've got Q1, Q2, Q3, Q4, which could be outputs. And those could be going to inductive or resistive loads. So the simplest application would be just think about a light show. If you wanted to set up a Christmas light show, this is primarily used for factory automation applications though. So if we go back to our ladder, this is input 1, so imagine that's a push button. We'll come over here and Q, we'll say output 1. So the two nice things about this software, again, is number one, it's free. Number two, it's got a nice simulation mode, so you can run it, and then you can input anything that could happen to this unit, and then it'll give you a display of what the output's going to be. So if we're looking at our ladder and we activate input 1, that's basically like just pushing the button, then we see that the rung turns green, and we get an output on Q1. Let me flip over to the unit, and you'll see here that this is active and this is active. We deactivate it, and so basically that's like a switch. I'm flipping the switch, the light's turning on. Now from there it can get more complicated. Let's just say on this particular unit, and when you set this up, when you open a new file, it'll ask you which hardware unit you're using, and they come in different sizes. So you can have different combinations of numbers of inputs and outputs depending on your needs. And if you get serious enough about this stuff and you go to buy a unit, it's a pretty low cost PLC. So that's nice. Let's do something a little bit more interesting though. Let's say we want to fire all of the outputs with that one button. Then we're going to come down here and let's see, Q2 and 3 and 4. And so now we've got one input activating 4 outputs. We come back over here and run the program and we test it and we see, bam, we can get all 4 lights. We'll stop this. Now down at the bottom here, each of these different tools that you can drop onto the ladder, if you hover over them, it'll label them. So you've got input, expanded input, that would be for a larger unit with additional inputs. Then you've got outputs. These are internal relays, or actually that's an expanded output. So if you just hover over each of the tools, you can see what they do. We also have the ability to have timers and counters. So let's try something else here. Let's put let's say input 2. So this is like a second button, and we're going to activate a timer. This will be timer 1. We'll make it a, this is where you can configure the timer. You've got all different kinds of options. You can just play with this and see what happens. But let's make it a, the base time will be 1 second. Let's make it a 3-second timer, okay? And then we will say that when that timer is activated, then we're going to fire 2 outputs. Let's do 2 and 4, and just make sure we got continuous current all the way through. So that's input 2 fires timer 1. Timer 1 counts for 3 seconds, and at the end of the 3-second cycle, this contact closes and these 2 outputs go high. So we'll run it, and again we'll do input 1. Bam, we get, oh, look at there, we're getting 1 and we're getting 3, but we're not getting 2 and 4. Well, why are we not getting 2 and 4? Well, we're not getting 2 and 4 because this timer is preventing them. That timer is not complete. So this is what we would call AND logic. It's not either or, but it's both and. So let's close contact 2, and then we see this counting up. 1, 2, 3, bam, it closes, and now we get our Q2 and our Q4. What happens if we open? Then we will 1 and 3 drops out, 2 and 4 stays active. Alright, let's see what happens if we just use input 2. Of course, this timer is going to count up 1, 2, 3, and then 2 and 4 go active again. So it's interesting. It's not letting 2 and 3 activate if the timer is not closed, but if the timer is closed, it can activate 2 and 3 even though 1 is open. So anyway, that's interesting, and that's why you have these debug modes. It's just to kind of, you build it and then you test it to see how the software works, and then once you get it figured out, then you can take it and actually hardwire it up to your machine and make it work in application. And that's how it works in the field. You debug, you test, and then once you make sure everything's set the way you want it, then you sign it off. I had built a alright, we're gonna not save that file. We're gonna open up this one. It's just another ladder that I built a few minutes ago playing with it. It's a little more complex. So let's show you this ladder. So we'll go input 1, push button 1 is normally open. We'll push the button to close the circuit, and then we'll get an internal relay. The internal relay will then start 4 timers. We got a 1 second, a 2 second, a 3 second, a 4 second timer. When those timers close, we will then get output 1, output 2, output 3, and output 4. Input 2 is normally closed, so when you activate a normally closed contact, it opens it, and when it opens it, all these inputs will fall out. So let's view this from the actual machine view, and so we'll go input 1, and then if we count 1 second, 2 seconds, 3 seconds, 4 seconds, we can see that all of our outputs have activated, and now if we push the button, normally closed, opens the circuit, and bam, they all fall out. So this is really cool. Basically unlimited number of options with the timers, the counters, the internal relays, and I've actually programmed a couple of these for actual applications in the field. 2 of them that I know are, we programmed them, set them up, and as far as I know, they're still running. One's on a machine that sews bags in a plant. Once the bag is filled with seed, then it runs across on the line. It runs across the sewing machine, and it's this TICO unit that's using photo eyes to activate whether the bag's present or not, and if it is, then it activates the sewing machine head. So that's pretty cool. Another one is water purifier, so that when a pressure sensor switch goes high and activates, then it changes valve positions, activates a back flush cycle, stops the back flush cycle, reverses the valve position, and then gives light indicators along the way, as well as a text readout to show you what position it's in. So if this were, say, remote on a panel, across the plant floor, you could look at the screen if it's programmed to that level, and you could see the status or the condition of the current operation. So anyway, it's pretty cool. Once again, you can download this for free and play with it, and it's just a pretty cool tool. So